Okay. So, here we have computer output. This is something we looked at back when we were doing linear regression first semester. So we want to just go back and remember what we learned from before. So, dependent variable. This right here is our y variable. So anytime you see dependent variable, that's the y value. So if they're asking you to write a regression equation, this is what you put in place of y. So you would put math test with a hat over it. That's that part of your regression equation. On farther down over here, anxiety level, that's your x variable. So that's your x and y. That 91.7, what does that represent? Y-intercept. This one below it, the negative 4.49, is this slope. And for what we are doing, we're going to call it B. Remember, we have when you do the linear regression in your calculator, it's ln reg a plus bx. B is our slope. Now, if you did the online activity yesterday, you were asked about this over here. So what do you think this means? We have a t value and we have a p value. Any ideas? Where else have we seen a t-test? Yep. So if we were to do a t-test on the y-intercept to see, is this a good indication of the y-intercept, that's going to be our t-value, and that's going to be our p-value for that test. If we're doing a t-test for slope, this value, that is our t-test statistic. This is our p-value that would go with it. So it's giving us all of this information in our computer output. So we're going to use this most of the time when you're doing a regression question on the AP test. It's using computer output. They give you this, they just want to know, can you find the things you need to find? Okay. So anytime we're doing a confidence interval or a hypothesis test, we need to know assumptions and conditions. The first one you guys should be able to guess because it's been in every single one that we've done. What do you think it's going to be? Randomization. So our first condition is randomization. So just like we've looked for in every single other test that we've done, we want to see that either the sample was randomly chosen or treatments were randomly assigned. Same as it's been for everything else. Okay. The other one we want to look for, if we're doing regression, we're talking about a linear function. So we want to know, is it linear? So we check for linearity, and there are two different ways you can do this. So you can check with a scatter plot. And there you're looking for, does it appear linear? The other thing you can look at is a residual plot. And there you want to know, is it randomly scattered? So it can do either of these two things. It just has to do one. You don't have to show both. Okay, so when you're doing this, when you're checking this condition, you'll notice you're either checking a scatter plot or a residual plot. You have to draw the sketch on your paper. Okay, you don't have to do the whole Tulsa principle and draw it out exactly, but you need a sketch of whichever one you did, and you need to say, does the scatter plot look linear, or does the residual plot look randomly scattered? You have to show which one you're doing. They will not be able to tell the difference between these unless you tell them this is a residual plot or this is a scatter plot, and it appears linear and it appears randomly scattered. You need to explain what you've drawn and what you're looking at. That will take care of our conditions. For degrees of freedom is going to be n minus 2. This is a little different. Since we have bivariate data, we have 2 variables, we subtract 2. You looked before at just univariate data, so we just had 1 variable, so we subtracted 1. Now we have 2 variables, so we subtract 2. If we are doing a confidence interval, the name of the procedure will be a t-interval for slope. So remember when we first started doing t-tests and t-interval, and I said you have to write 4 means because there are other types of t-tests and t-intervals? This is where we're seeing that. So you can't just write t-interval. You have to say for slope because that's what we're doing. And here, we're going to mark this out. That was supposed to be taken off and it didn't get taken off. Okay, so for do the math, here is our formula. B, our estimate of the slope, so that's going to be straight from the computer output at the top, plus or minus the t critical value, this is from the table, times the standard deviation, but here we call it standard error for the slope. This is just standard deviation. Yeah. So when we look back at our computer output, we see this is our slope. This next column you see is SE coefficient, that's standard error for these numbers. So this right here, this 1.55, that's our standard error for B. So that's the number we're going to use. So we have our slope value, our estimate. We have our standard error. So those are going to plug in these 2 places. We just need to look this up on the table. So we're going to look at degrees of freedom is n minus 2. So here n equals 24, so this is 22. And I knew that. Oh, why am I doing that? So n is 24, degrees of freedom 22, and I'll show you where I got that. Right up here, it told us this is my degrees of freedom, 22 degrees of freedom. The 24 is my sample size. I subtract 2 to get my degrees of freedom of 22.
Will you like that for questions? Will it give us some modules for modal summary?
Yeah. Then we're going to give you computer output, and you're just going to have to find everything in there.
So it pretty much gives us like...
Yeah, it pretty much tells you everything. Okay, so to find this value, I just want to look at my table. I'm going to go to my T table. I'm going to find along the bottom. It didn't give us a... Yeah, so we're just going to say, we're going to make this a 95% confidence interval is what we're going to create. So I'm going to go to 95%. I'm going to go up to 22 degrees of freedom. And that's the value. 2.074. So that's that T asterisk. That's our T critical value from the table. .074. So when I'm plugging in, I can just put these straight from the computer output up above, and then from the table, and then the standard error was the 1.55.
You have 2.074 for the
Yes.
T.
Right up here.
What is the 1.55 value?
That is our standard error of the slope. So that's our standard deviation for the slope value. Okay, so to find the confidence interval from this is what I put into my calculator. So I just did the 4.49 minus this, and then I did 4.49 plus this. And so that gives me my two values for my confidence interval. You always want to go smallest value first and larger value second. So 7.7047 is negative 1.2753. So that's my confidence interval. Anyone else questions on that? Okay. For hypothesis test, we're going to call this a t-test for slope. So you'll notice up here, like I say, we use the letter B for our slope value. So the B is our estimated slope. So here when we talk about our hypothesis, that's going to be our parameter for slope. And it's just the Greek letter beta. So it looks kind of like an uppercase B with a tail. So we'll say in HO, it equals 0. So what this says, if the slope is 0, that shows no relationship. We can't say it's positive. We can't say it's negative. We just say there's no relationship. That's basically what this is saying. So here is going to be some kind of inequality, either less than, greater than, or not equal. Most of the time, they just want to know, is there a relationship? So most of the time, it's going to be not equal. But they may say, is there a positive relationship, or is there a negative relationship? And that's when you would use a less than or greater than. So look, is the slope positive or is it negative? Okay. So beta through slope, the equation. Between, and we would just put our x and y variables. So here x was anxiety level. And the y was math test.
Why do they call it anxiety level? Because it gives you anxiety and you can't do it.
What I'm trying to say, when you're more anxious
Stress
over a
level.
math test, yeah, you're going to possibly not do so well.
When I feel like I did really well,
So our t value to get this, you just do it's basically the z-score test. You do our estimated value, so our b, minus what we think should happen, our beta, over the standard error of beta.
Wait, so B or beta? Yeah.
So b here,
You said
beta
standard-
here,
you said standard error.
standard error.
You said standard error of beta.
Oh, yeah, sorry.
Right.
Standard error B, sorry. I didn't mean to say that. I wrote what I meant to say. But I said something. Okay. So, our B is what we had up here. Is negative 4.49. The beta is what we had in our, what we're assuming is true until proven otherwise. So here beta is 0. Almost always we're going to test 0. Now I talked to you guys a little bit a while back about question 6. I have seen a question 6 where they tested, is it 1? So that can come up, all you do is make it 1, and then you do everything else exactly the same. So don't let it freak you out if they have you test for something other than 0. It'll be fine. Our standard error is going to be 1.55. This is just from up in the table. I don't know. Because I'm thinking about a million other things besides what I should be thinking about on here. Okay. So, here we're just basically doing this minus 0 over 1.55. So, you're just really dividing these two. So when I divide it, I get negative 2.8968. So if you compare this to the value that was up here, negative 2.89. So that's how they get this number, is by doing the calculation we just did. Okay? Now, how could we decide whether to reject or not? But we don't know the p-value. But we do know the critical value. We have this number up here, this 2.074. That tells us how far anything out here will be rejected. Anything farther than that from 0 is so far out that we're going to say this is not something that we expected to happen. So we're going to reject. We're going to say it's no longer 0 because what we have is so far away from it. So if I think of where this value lies in that number line, it's over here. So this value is out here in the rejection region, so that means we reject HF. This T is less than the T critical value. Or sorry. The absolute value of T is basically greater than the T critical value. Maybe a better way of looking at it. Because look, this critical value that they give us is a positive number. Every critical value we get on our table is positive. So our critical value is really, this one is telling us how far away, it's a distance. So the critical value is always going to be positive. So we're really saying if the absolute value of this is more than that, then we're farther away than the critical value. We're in the rejection region. Go back to what?
The way you wrote it before, I understood it.
Yeah, but the T critical value is really 2.074. We don't want everything over here to be reject. We just want the things that are farther out here and farther out here. We want things that are more than this distance away from 0. So we talk about that by absolute value. Other questions? Okay, let's look at the backside. Backside is just some multiple choice questions that are things that you may encounter. So here it's looking at the body weight versus brain weight of some individuals. So it says 22 non-human mammals were measured. So that's our sample size is 22. So that's what they give us right there, n equals 22. So how much is my degrees of freedom? Good. So they want us to just assume that all the conditions are met. Don't have to meet any conditions. We just want to write out what is the equation we would use for a 95% confidence interval. Well, what is our estimate? So what is our estimate for slope?